Okay, everyone. Welcome back. This is Mr. Lundy, and today's lesson is going to be all about um, learning how to correlate sedimentary rock layers and understanding a little bit about what we call index fossils. So to do this, I thought I would set up a demonstration in my backyard and have a little fun with this, but I'm going to ask that you have an imagination as you go through this with me. What we have here is, this is my backyard, and I own some property up that back hill. So what I did is I set up 3 mock sedimentary rock layer, we'll call them stations, and we're going to be traveling to each one via the four-wheeler, which I thought you might like to see. And we're just going to be looking at how you can correlate them, which means to connect similar rock layers based on their characteristics. Okay, so let's start out. Let's call this station 1. Now, these wood boards here, we're going to pretend they represent what are called beds of sedimentary rocks. So just think of them as layers, individual layers of different kinds of sedimentary rocks that stacked up one on top of the other. So as a review, we know that sedimentary rocks form in flat-lying horizontal layers, usually in water. So like think of like when sediments are sorted by water and they sort of fall to the bottom of a lake or an ocean basin, and they sort of accumulate in flat-lying layers. And then the next series of events puts more down, and then more and more. So this is known as the law of horizontality. So basically, all sedimentary rock layers, if they are undisturbed, they will be found in a horizontal lying orientation. Okay. Now there is the other law having to do with sedimentary rocks that I'd like to talk about, which is again the law of superposition. Now you might remember that as these sedimentary rock layers are deposited, try to think about the one that came first. Which one would be the oldest? Which layer came first, right? So if you got a stack, which one would be, where would the oldest sedimentary rock layers be, right? You're right. So down here at the bottom, the oldest. So as you go up, you get younger and younger in age, or you go up through the geologic time scale towards the present. Okay, so that is the law of superposition. So 2 laws, the law of horizontality and the law of superposition now. Okay, so I used the sedimentary rock patterns on page 7 of your reference table here, and using Sharpie, I sort of colored these in. So let's try to just figure out what we're dealing with here. So a geologist might come up to station 1, he sees a bunch of layers. He knows they are undisturbed because they're horizontal. He knows the oldest are on the bottom. So what are we dealing with here? Look for a pattern. This isn't perfect, but black dashed lines with maybe some smaller lines in between the longer ones, I believe. Haven't looked at it in a while. I hope I'm right anyway. So what are we dealing with here? Okay, if you said shale, you are correct. Now, shale is very fine-grained clay particles that get deposited in very deep, calm water. Okay, let's move up. What do we got here? It looks like a block pattern. We have it here, here, and here. Looks like sort of a cinder block wall pattern. If you said limestone, you are correct. So we have 3 sections or layers, beds of limestone, different beds of limestone. And then finally, what do we got here? A bunch of dots. Yes, sandstone. Okay. Now, limestone gets deposited, think of like a coral reef environment. a little bit closer to shore, not as deep, not as calm as where the shale gets deposited. And the sandstone, well, where do we have a lot of sand today? Where can you find a lot of sand? Yeah, at the beach, right? Or the desert. So if you find sandstone, you're more than not dealing with an ancient beach or desert. Okay, so deep water, medium, shallow, right? Okay, so it looks like the conditions changed. You can actually see a lowering in sea level here in these sediments. So it went from deep to shallow. Okay, now finally we have some fossils, which are the different symbols here. We've got X's, we've got O's, and I think in one of the locations we see a W. Okay, so let's review the law about, or the not the law, but rather the rules for index fossils. So these letters, these X's and O's, are going to represent index fossils. Now remember, to make a good index fossil, the fossil needed to only survive in the geologic record for a very brief or short time. So what that means in the rock layers is you don't want to see it in a lot of places vertically, because this is old. This is young. From here to here might be 1,000,000 years. So you don't want the same fossil appearing in a vertical sequence a lot. You want it just one layer or one section if you can find it like that. Okay, what's the other rule? The index fossil or the organism must have occupied or survived over a wide horizontal distance on planet Earth. So what does that mean? It means, imagine it living in both the Atlantic Ocean and the Pacific Ocean and the Indian Ocean. Okay, so all around the world, this organism lived. And then it only lived for a short period of time, and then it went extinct. It died. So if we find it down here, we're never going to see it again. We're only going to find it here, and that's it. Okay, but if we go to Australia, we might find it. If we go to Asia, we might find it, but it will be only in that same layer over in those different locations. Okay, so let's take a look at this. What do we got? We got X's and O's in this layer. We don't have anything in these. Here it looks like we just have X's. Here we have X's, and here we have nothing in the shale. Okay, so as a geologist, I would have my field notebook and I would be writing this down. Okay, location 1 or station 1, this is what I've got. And I don't know which one makes the good index fossil yet, because we haven't identified, well, we have, but we're going to pretend that we don't know enough yet, really, and we're going to go to a few other sites. Because we want to, remember, we want to correlate. We want to connect this layer to other layers that could be thousands of miles away. All right. Off to location 2, and we're going to do these a little bit quicker. Okay, so we're going to pretend that I flew across the Atlantic Ocean and maybe now I'm somewhere in Europe. And I'm looking over here. Ooh, I see some shale at the bottom, but this time it's got some X's in it. And I see more shale with more X's. Then we're into some limestone with X's. Limestone with X's. Limestone with X's and O's. And finally sandstone with nothing. Okay. Where's location or station 3? Okay, way up in the woods here. Here we go. Now again, we would record this. Now we're traveling over a wide horizontal distance now, right? do we have here? All right, shale with more shale above it with some X's, more shale above it with more X's. Then we have a layer of limestone with a W. Okay, so that's new. W is new. Then above that, more X's and W's. And then above that, X's, O's, and one W. And then sandstone. So this location is the only location that has a W. The W does not exist at the other two locations. So way down there, no W's. But we do have X's and O's. Right? Now I want you to try to think vertically. Which letter only occupies a small section of geologic time compared to the rest? Okay, so to be a good index fossil, we want it to have appeared in all three locations, but only in a limited time span. So in only one of the layers. So which letter fits the criteria for the best index fossil? And by the way, we could take a string and we could go from whatever layer that is, because we know that that animal only existed for a short period of time, but it happened all over. So if we can find that layer, we can connect it to the other layers, and we know that we're dealing with the same place in the geologic time scale, the same time. And that is how geologists can do something called relative age dating. We can get a relative age when an event occurred. Okay, so which letter? If you said letter O, you would be correct. Now, why isn't it W? Well, it's not W because W only is found here. And index fossils have to be found in multiple locations. Why isn't it X? X is found in all three places. But remember, the X's were found in various different layers horizontally. Okay? All right. Well, I hoped that made sense and that you enjoyed it. Let's discuss it and see you later. Bye.